Imagine a world where the ordinary rules of existence simply don't apply, where being alive and not alive, being here and not here, are not mutually exclusive. It sounds like the stuff of science fiction, or perhaps a philosophical riddle, but this is the actual landscape of quantum mechanics, the most successful and yet most perplexing theory in modern science. At the heart of this quantum world lies a concept known as superposition. In the everyday world we experience, things are one way or the other. A light switch is on or off, a cat is alive or dead, you are in one place or another. But on the tiny scale of atoms and subatomic particles, the rules shift dramatically. Here, particles can exist in a superposition, a blend of multiple states at once. To make sense of this, let's travel back to the 1930s, when physicist Erwin Schrödinger devised a thought experiment that has since become iconic. Picture, if you will, a cat placed inside a sealed box. Alongside the cat is a device containing a radioactive atom, a Geiger counter, a vial of poison, and a hammer. If the atom decays, the Geiger counter triggers the hammer, breaking the vial and releasing the poison, killing the cat. If the atom does not decay, nothing happens, and the cat lives. According to the quantum rules governing the atom, until we open the box and look, the atom is in a superposition of decayed and not decayed. By extension, so is the entire system. The cat is both alive and dead at the same time, existing in a liminal quantum haze. Of course, in our experience, when we open the box, we find a cat that is either alive or dead, never both. This raises a profound question. Where does the strange quantum world end, and our familiar everyday reality begin? Is there a threshold beyond which superposition ceases to exist, or could it, in principle, apply to larger systems? Even something as complex as a living being. Researchers have spent decades probing these questions, trying to bridge the gap between quantum weirdness and our macroscopic world. In laboratories around the world, physicists have coaxed larger and larger objects into quantum states. Tiny molecules, clusters of atoms, even small mechanical devices have been placed in superpositions, blurring the line between the quantum and classical. But what about life itself? Is it possible that living systems, including humans, partake in quantum superpositions? Could we, in some unimaginable way, be both here and not here, alive and not alive, just as Schrödinger's cat seems to be? To answer this, we have to consider what superposition really means. In the quantum realm, a particle, say an electron, doesn't have a single definite position or energy until it is measured. Instead, it exists as a wave of probabilities, a mathematical description of all the places it might be, all the energies it might have. Only when we look, when we make a measurement, does the wave collapse into a single outcome. For tiny particles, this is not just theory. It's been confirmed in countless experiments. The famous double-slit experiment, for example, shows that a single particle can behave as if it passes through two slits at once, interfering with itself until observed. But as we scale up to larger and more complex systems, something curious happens. Quantum effects seem to fade away, replaced by the solid, definite world we know. This transition from quantum ambiguity to classical certainty is still not fully understood. One leading idea is called decoherence. As a quantum system interacts with its environment, colliding with air molecules, absorbing stray photons, exchanging heat, its delicate superposition is rapidly destroyed. The quantum wave function becomes entangled with the countless particles of the environment, causing it to appear as if it has settled into a single definite state. For a living creature, which is constantly interacting with its surroundings, decoherence happens almost instantaneously. The many trillions of atoms in your body, each jostling, vibrating, and exchanging energy, create a cacophony of interactions that wash out quantum effects. In practical terms, it seems impossible for something as large and warm as a human to exist in a superposition, at least in any way that we could observe. And yet, the story doesn't end there. In recent years, scientists have begun to probe whether certain aspects of life might exploit quantum phenomena. In photosynthesis, for example, plants appear to use quantum coherence to transfer energy with extraordinary efficiency. Birds may navigate using entangled particles in their eyes. Even the sense of smell, some researchers propose, could involve quantum tunneling. These discoveries suggest that nature may have found ways to harness quantum effects, even in the warm, wet, and noisy environment of living organisms. Still, these are highly specialized microscopic processes. The idea that a whole organism, let alone a conscious being, could be in a quantum superposition remains, for now, firmly in the realm of speculation. But what about consciousness itself? Some theorists, most notably physicist Roger Penrose and anesthesiologist Stuart Hameroff, have suggested that the brain might perform quantum computations and that consciousness could arise from quantum processes in neuronal microtubules. This is a controversial and highly debated idea, lacking conclusive experimental support. Nevertheless, it raises a tantalizing possibility. If consciousness itself is rooted in quantum mechanics, could it possess properties that defy our classical intuition? Could we, in some deep sense, be both present and absent, aware and unaware, in a quantum sense? For now, the evidence points to a clear boundary. While individual particles, and perhaps small collections of molecules, can exist in superposition, the overwhelming complexity and constant interaction of living systems with their environment makes it practically impossible for a whole organism to do the same. Schrödinger's cat, in reality, is either alive or dead long before we open the box, thanks to decoherence. Yet, the story of superposition challenges our understanding of reality itself. It forces us to confront the limits of knowledge, the nature of observation, and the profound strangeness at the heart of the universe. Quantum mechanics has shown us that the world is far more mysterious than we ever imagined. Particles can be in many places at once, outcomes can be both possible and impossible, and reality, at its core, is woven from probabilities rather than certainties. So, could you be both alive and not alive at the same time? According to the laws of quantum mechanics, the answer is yes, but only if you're willing to shrink down to the scale of atoms and embrace the wild, unpredictable rules that govern the very small. For the rest of us, living in the macroscopic world, we remain firmly on one side of the paradox or the other. Still, the quantum world is always there, lurking beneath the surface, reminding us that reality is far stranger than it seems. In the end, the greatest lesson of quantum superposition may not be about cats or consciousness, but about humility. The universe is more complex and more wondrous than any of us can fully grasp. And as we continue to explore its quantum depths, who knows what other paradoxes and possibilities await us, challenging our understanding of life, existence, and reality itself. Subscribe now for more mind-blowing facts, concepts of science, and much more.